Today I want to introduce you to, sometimes messages don't arrive at the time we really want to, and sometimes later, sometimes earlier. We all have to deal with them, and I want to talk about asynchronous programming today with you. Okay, so we will talk about a little bit of the history of asynchronous calls over the years, combined with my personal history of dealing with them. Look at Redux-Sagas. Who actually of you is working with Redux-Sagas? Okay, who heard of Redux-Sagas? Okay, less than the people using it, okay. Then generators, I want to touch on that, because they are like the backbone of Redux-Sagas, and then show you some example using IoT, some Bluetooth devices. Good. So how did I start my whole web development career? I got a task to build a small web application after I did an online course first, and somehow I came up with some shampoo shop, and I used some, and there I believe I didn't really was a web developer, rather a web plumber, because my code was trying to use jQuery, mixing it with JavaScript, getting something done, not really knowing what I'm doing at this point. But I think maybe many of us have dealt with a lot of callback code, which gets difficult to handle. And so here it's a bit of skewed pyramid of doom. And maybe when we talk about falafel here in the Middle East, we will soon see another pyramid of doom. I thought of picking this example, which will follow us for the next while, where there are some components to make falafel. The money is just there to buy some chickpeas. And we have to eat it somehow, which is the callback. And there we can also quickly end up in a kind of pyramid of doom. Some call it a callback hell as well. Good, we will take a look at it closer, just for the example of this talk. So we will have some ingredients that I looked up online, and I think many of you perhaps can do this much better. And then I think 10 shekel is enough perhaps to buy some chickpeas, and we will try to eat it with a console log statement. Good. So in an ideal world, we first make falafel, and then we eat it. It's like the order we want to. But somehow when we use callbacks, we first have to put up there as a callback the eating of it, and then later we make the whole thing, and then somehow it pops up as a callback again. So it's really hard to reason with codes like using callbacks a lot. And it's much nicer when you really have it in the order, in a synchronous order. You make falafel, and then later you eat it. So there you would go through in a synchronous way, would be nice. You get your chickpeas from the store with some money, you make a mixture out of all the ingredients with it, and in the end you deep fry everything. You get a falafel, and you can eat it. Great. This would be wonderful for us developers. But unfortunately, there's something else in the equation, which is the user. And they might not be so happy with having to wait and not being able to click on anything in the UI for the whole time. So the ECMAScript committee has really thought hard over the years to deal with this problem of how can we make asynchronous programming easier so that everyone is happy, the developer and the user. And so they came up with promises. Just to repeat everything to get to my main talk. And so here I created 3 functions which all return promises. These are the same ones as before, but now they return a promise. So they have resolve and reject. There's callbacks, in case everything went well or not. And in a promise, you have these 3 states of pending, fulfilled, or rejected if something went wrong. Probably a review for all of you. And I kind of modeled this with set timeout, because you can never rely on internet. So I did like that, which you will see later. And I resolve it with just some synchronous function where I did just some, basically some statements just so we see something happening when we do something. Okay, so how does it look like with promises? Already a bit better, right? So we start when we make the call, we start here with the first. It returns a promise, which we can then chain with the then command, and can use that for the next promise and chain it further on. And in the end, we get returned a promise, which we can then again chain into finally eating the falafel. Good. But still somehow this doesn't look completely similar yet. And I'm not completely happy. And probably you all know what's coming next. Async-await, where it looks really nicely. We have actually our synchronous code looks very much like our asynchronous code, and that's the only difference here. And just to go through there line by line, we first make the falafel and then we eat it. Good. So, this is really cool, but seems like a bit of magic. Yeah, how does this thing actually work? When we just add 4 new keywords and we're happy. So I first didn't care much, but still my life moved on. So I didn't write any dubious shampoo shop stores anymore with jQuery, but I got in the world of React and began developing with React Native and Redux. So there I was really happy about unidirectional data flow, which probably you all know, and was really happy working with it. And the combination of React and Redux solved a few nice problems and gave me this single source of truth in the store, that state is read-only, and the changes are made with pure functions and only going through the pipeline via these actions in the dispatcher. But is there some help for asynchronous events in this case? So there was Redux-Thunk, which I could use to then have some async effects and also dispatch some actions from within. Okay, that's nice, but then things got more complicated and didn't get useful, and then I came across Redux-Saga, where I could model a more complex form of dealing with asynchronous code, and really loved it. Why also? Because I work a lot with Bluetooth beacons. Who of you knows about Bluetooth beacons? Okay, not that many, so yes, here. So there I'm holding one in my hand, and here as well. And so these are small Bluetooth low energy emitting devices, and they are built for just always sending out a small Bluetooth signal, but doing it for a long, long time with only 1 or 2 batteries they have in there. So they're not really smart. They send you a signal with a unique ID telling you, hi, I'm here, and whenever you come close with your phone, you will be notified of that. Has the name after a beacon, so that's also called, this tower is called a beacon, sending the light in different directions, kind of to show what the beacon is doing. And here's also one opened up, so there's a small chip in there, and you've got batteries, which are usually like coin size, and applications for beacons are, for example, when you walk through a supermarket and then you go across the milk section, it would notice you are close by and maybe give you a special deal or offer for it. Because there's this one beacon type I spoke of, just sending only signals, and there are other ones which can even, the so-called Eddystone beacons, which can even send a URL to you. But I'm dealing now in this demonstration today only with the ones which send a single, just the ID, just a more stupid signal. And they come in different shapes as well. So, and here with Bluetooth Low Energy, the signal comes and goes as it wants. You probably all had the experience when you try to somehow connect your phone to some Bluetooth speaker, and then you're like trying to get this thing connected. It won't connect. You give up, you throw it to the side, and then suddenly, ding, it connects. Maybe some of you had this situation. It's like really unreliable, and there needs some way to really get hold of all these asynchronous signals coming in and out, or coming in. So Redux-Sagas. And so for those of you who don't use it so far, you can really think of it as kind of being different threads kind of each being a saga, which you can start, pause, or cancel, and you do this all with Redux actions. And you can also dispatch actions from it. So it's kind of really embedded into the whole Redux ecosystem, but you can, with that, do several things kind of in parallel. So how does this look like? Don't look at this grayed out part on the left-hand side first, but these are just some of the commands, like the take every, and take latest are kind of listeners. They listen for some actions from the Redux store coming in, and so it's kind of really waiting there. You have your single, you can say thread or saga, waiting for some action coming, and as soon as this action is dispatched, you can then, the flow continues, and it really suspends and stops at this point until that action, or maybe even an array of actions, occurs. You can also then, as I said, kind of dispatch actions, and so actually take and put are kind of the input and output of Redux-Sagas, you might say, of how to communicate, how it can communicate with the world, and how it waits for incoming signals. So there's another so-called effect in Redux-Sagas where you can make calls to anything, to a function returning a promise, to just a regular function, or even a saga. You can just call them and it will do whatever. And that's, for example, suitable to make some API calls. There's also a select statement. That's where it also comes in, that it's connected to Redux. So here you can throw in a selector and get something particular out of your Redux store. And then there's the fork effect. And here you can start a background task. So every fork effect starts a thing called task inside the Redux Saga world, and with these tasks you can also keep track of them and have different things, these different threads kind of starting. Good. So you always saw this yield here standing before. So now let's deal with that. So this yield was also actually Redux-Sagas was the library which made me aware of generators. The first time, because I used that and then came across and then wanted to dig deeper. And yes, boom, an animation. So what are generator functions? Let's look into that a little bit. So we have a generator, and generator is yielding things. And at each yield, the whole program will suspend. And only if then the caller of this generator decides to go further on, it will continue. And so every generator, if you define it, needs some caller or runner to run the whole thing. So we have here, for example, creating the generator, hello world, and so here I'm console logging what the generator gives us. And let's take a look at what it does. Can this be seen? Okay. So I already prepared something, like in a falafel cooking show, perhaps, but this is now not falafel. And I will run this with Node, and let's see, we have 4 times calling next on the generator, and here it's really working like an iterator. We're just telling give me the next value, push it to me. And we see the output of the next call is always a value, and the value which is yielded. And then there's given a done, a Boolean, which signifies whether we already reached the end, the return statement of that generator, or we didn't. And we see I already also put in, so the third call gave us a done true. After that, we don't get anything useful anymore. And we get undefined here, because JavaScript is always nice to us and still runs even nonsense. And I show you right away the next one, because it's a bit cumbersome to switch over. So here is a magical thing happening inside the generator. We've got an endless loop going on. Wow, how can that even work? It's because we have a yield inside the endless loop, and so the execution of this program will suspend unless we call next again. So let's see what's actually happening here. We call this one. So here we're starting, initialize this generator with a 7, and then it always adds 10 to it. And here we see 4 values, and this would still continue for some time. Let's maybe take a look at the way it's now. So now for the last one, I didn't return the value, but we see it's not done yet, and it will never be done. So here we could always get new values, and we see this coming in handy when we just want to range for beacon signals and just want to wait and go on and continue until ever after. Okay, so this was that. It's kind of a magic thing, now being able to call an endless loop. And another cool thing, so a generator is not only an iterator, but at the same time, it can also observe. It's an observer as well. So we see here that actually we are waiting here for something in the left side. The generator is waiting to get something returned after the yield statement. And the generator can do that. So when you pass an argument to the next call, it does not only try to get the next value, but it at the same time also returns. Even like before that, it returns whatever you give it as an argument and replaces the whole right-hand side with the yield. We will see that also in action in a moment. So I wanted to understand, so at that point then I got curious because somehow that looks really similar to how generator functions kind of, the syntax looks really similar. And then I was kind of wondering, does this have something in common, or why is it just coincidence? And it made me curious to find out, and that I want to now quickly try to demonstrate to you that they really have something in common. Actually, pretty much. So we're coming back to a falafel example. And so yeah, here's when you are curious about the recipe. You can get it from there. And so yeah, this is just eat falafel function, which is just returning some console log statements and just something to fill the whole thing out. And here we have our promise returning functions, which I showed you before. And so here I now defined a generator. So the generator I always define with the star, and whenever I have this function defined with a star, I can use yield statements within that function, this generator. So, and then I also initialized this generator called make falafel with money, which I defined above, 10, and all these ingredients. So now I would try to run the generator and do that with the next command. And let's see what we get out of there. Oops. So we get a pending promise. Oh, I didn't even know that you don't have to add .js. Okay. So we get a pending promise out here, and it's not done yet. So let's see. So we take this value, which is a promise, and let's store it now. And we want to see how we can go on. So we are now trying to write this caller, this runner of this make falafel thing, which has all functions with promises. And so let's then continue, but we see that actually after the first call of yield, we have to return something to chickpeas. And this what we want to return is what do we do with promises? We try to resolve them. So we can now go take this promise, and whatever we get out there, we can then call the generator on it again, but this time we now return chickpeas to it. See, but this, yeah, let's do that. Okay, but now I didn't console log anything. Let me do that here. And let's really see whether we can get our chickpeas back. Tadum. So we see we couldn't just run generator next here and throw in the value. We had to first, because it's a promise, we had to first resolve it. And then we could pass it on. But we're still not done with the whole generator yet. Actually, when we lock this one, we will see, what should we see? That we are still not done. So we can actually play this game on further and continue. And so this is a not really intelligent way of writing this whole thing. But I hope maybe, like, sometimes I like to do things in a stupid manner, so kind of I myself get the concept faster. So I've got this promise. So because now we are calling, the cool thing about next, so we're returning chickpeas here, and at the same time yielding the next value, which again is a promise, because getMixture is returning a promise, and we get it as the value. So let's also now here return this one. This will be the mixture. And we again call the generator. Oops. And return the mixture. Okay. And we want to be completely happy and see whether everything arrives. So what did I do wrong here? I didn't resolve the promise, so this is a then. It's still wrong. Huh? Yes. Thank you. It's all a test. So here we're getting a mixture back, and we do it a last time to try to finish the whole thing, and then we want to reveal what's coming out of there. So, oops. Perhaps I could have prepared this one, but this will already be the finished falafel. Oops, sorry. And returning this one. Yeah, because this one, probably. And we're getting a falafel back. So we're getting everything back on the side of the generator. And so, but what did we actually do on that side? So we are dealing with several promise returning functions, which we return one after the other. Let's maybe first make this a function, or like let's call it the caller, which accepts a generator, and then does all of this. And then we call that with our generator, which is called make falafel. And we should hopefully get the same thing. No, we don't. Can someone help me? Huh? Here is the promise. No. In line 106. Of course. Okay. No, wait. Now I'm really confused right now. What's? The generator's already, of course. The generator I'm passing. So. Yeah. And I take this one here. And which is home ingredients. Okay, thanks for bearing with me. But so what we did here actually is we did the same thing as actually here running async-await, which I already, no, it's the time. So this actually leads to exactly same result as async-await. And so we kind of implemented in a very naive way async-await. So I quickly now want to show you still. So and actually that's also how it's implemented in the V8 engine. And when we go back to our beacons, I want to now show you an example. So what's interesting for us is to uniquely identify a beacon. So that's what we get returned when we search for one. And the RSSI. This is gives us the strength of the signal, which we can then use as an indicator of how far the beacon is away from us. And so here you see right now my phone. There's a small app, and now I start discovering beacons. And so I have 3 beacons with me, and I need 3 brave volunteers to take a beacon and try to identify by moving around a little bit. One more is here. Which beacon you have, which color you're having. So it indicates here how far you are away from my phone. The black thing is my phone, which is here. And maybe you're already a bit too far away. And you can see that the signal, you see sometimes it's appearing, disappearing, and that's the thing working with hardware. You just get a total different layer of potential issues. It could be the environment. It could be the battery is low. Oh, okay, have you already found out your color? So one could come very close to me. Yeah, that's probably the. Oh, now it's gone. And no, the blue one is further away now. So you're probably not the blue one. You're probably the red one because you're right here, and the signal is. Huh? Yeah, the closer to the black device you are. So yeah, you see, the signal is not reliable often, and so there you have to then work with that signal and try to smooth it out to somehow get it into a better shape. And I just really briefly wanted to show you that in a Redux-Saga, there is no real space, like when you have to look at the middleware, for Bluetooth signals to have it natively in there. And there's a cool feature in Sagas, which is an event channel, which you can set up. Thank you. Which you can set up and include into the whole ecosystem where I show you how it's done in action. So when you have your Saga, you yield one by one, initializing the whole beacon library, which is called contact. And then in this line, the last one, which can be seen, you initialize the channel, which will then emit all the time when a signal arrives, will emit a signal which you can take. So you can not only, like you saw, the take was the input, the waiting for a listener, waiting for some action arriving from the store. But now you can not only listen to actions from Redux, but also to signals from some channels you define yourselves, and I defined it with the beacon listener. Okay, so I hope you got a bit of an intuition, how working with beacons can be. And if you want to try it out yourself, there's a tool for Mac, which is called Mac as Beacon, and you can have your computer simulate an iBeacon. And so you can play around with beacons yourself right away without having to purchase any beacons. Okay, thank you. You find me there on social media. Thank you, Mike.